Hello and welcome to this new C tutorial. This is part 8 and the last part of how to program in C tutorial. Okay, in this part we will learn the stuff that is left, right? We have learned almost everything in the previous tutorials, right? So in this tutorial we will cover a couple of new topics, okay? Like for example, we will start on how to read files. Okay, so imagine you have a file, read and write actually. You have a file in your computer and you want to write to it or read from it. Okay, so since we don't have a file ready to task to read, we will start by writing a file. Okay, awesome. So to write a file, we don't need anything else. The same stdio.h library will help us to write a file. Okay. So for that, we're gonna say file. Oops, let me see. File in uppercase, pointer, and I will call it my file. Okay. And I will set these to f open. Okay. And as the first parameter, I will pass the name of the file. For example, my file.txt. Okay. And the second parameter, I will pass the read or write mode. In this case, I will write, so I'll put a W, and I'll do it in binary way, so B, write binary, okay? Awesome. So what do I want to write to that file? Well, I will define a string, so I'm going to say char pointer string, and I'll put something like hello file, okay? So this is the string I will send or write to the file. So to write to the file, we do fwrite, okay? And as the first parameter, we will pass the string we want to write, which in this case is called string. And the second parameter, we will pass the string length. So you can change it, but let's pass 10 as a string length. And as number of elements, we will pass 1. And lastly, the file pointer, which is called my file. Okay, so this will write the file to our computer, right? And now, after we write the file, we have to close the file pointer. To do that, we're going to say fclose, and as parameter, we'll pass the file pointer name, which is my file. So these 4 lines, only these 4 lines are used to write a file. This will create my file.txt in the current directory. We'll get this hello file string and we'll write that to it. Okay, so let's try it. Okay, so we open the terminal. Let me clear this and I will compile the program. Oops. I will compile the program and I will run it. C1. And it exits as you can see right here in Visual Studio Code. We have this new file called myfile.txt. We can also list them by typing ls on the terminal. As you can see right here, we have myfile.txt. If we open this file, here you can see that it contains the hello file string we wrote to it. So we have created a file called myfile.txt and we have wrote this content to the file. So pretty simple how to write a file, right? But now we will learn how to read a file, okay? It's pretty similar to process. So we start to create a new file pointer, and I will call this read file, for example. And I'll set this to fopen, and here I will pass the name of the file again. So I will read the file I just wrote. I'll call it open my file.txt. And instead of WB, which means read binary, I will pass, which means write binary, I will pass RB, which means read binary, because now I will be reading this. Okay? So that's how we read the file, and we will create a char character array. For that, we can say char read string array, and the size of it will be 10 elements. Okay? Read string, sorry. Okay, so now that we have done this, what we have to do next is actually call fread. Okay, so you're gonna say instead of fwrite we call fread, and as the first parameter we will pass the string. In this case it's called read string, the destination of the read action. We'll pass the size of the string, which will be 10, the number of object, which will be 1, and the file, which is read file, right? And again, after we have read the file, we have to close the file. So you can say fclose, and we'll pass read file. So basically the same, but now we are reading into a character string, right? So in order for us to know that the read worked, we will print what we just read. So we can say printf double quotes %s new line, okay, and I'll pass read string, okay. So now let's run it and check if it works or not. So compiling it and now running it, and as you can see here we have hello file followed by a 0 and by a strange symbol. So why this happens? Well, basically this happens because we are not null terminating our file, right? So to null terminate our file, we'll do the or string will do the following. Instead of 10 right here, we will put 11 here, and here we will still read 10, okay? And after we close the file, we will put the 11th element, or which will be accessed by 10. So we'll be read string at 10, and we will put this to the null terminator, okay? And we will set it to single quotes \0. Okay, so with this done, we now have set our string with its null terminator. Now we will run this again to check if it now works. And yes, it now only prints what we want, which is of course awesome. So this null terminator, as I explained in previous tutorials, tells the system where the string ends, right? So that's the only function to it, right, actually. So now we know how to read files. And now we will learn how to kind of handle some errors. For example, let's imagine we don't have a file. For example, I will try to read my file 1, okay? And what will happen then, okay? So if I run it, it says segmentation fault, but we don't know what that means, right? But because we don't know, so here we have to check if the read operation was successful or not. Okay, so to check if the read operation was successful, we'll do the following. We'll say if read file equals to null, okay, so if read file equals to null, what we will do here is that we will check for errors, right? Okay, so to check for errors in C, we will have to import a library, which will be the errno.h. So we're gonna say include errno.h. Okay, this library will enable us to handle errors and to get what's going on with our system, right? So after we've done this, we want to print what went wrong when we try to read our file, a non-existent file actually. Okay, so to do this, we're gonna say printf, and you say error number or error code or something, and we will specify a %d and then \n, and what we will pass here will be errno, because the library will store in that variable the error that occurred, right? So we did that. And after that, we can also call p error, which means print the current error. And as title or something to this, we can say error and colon. And apart from printing this will also print the actual error. Okay, and when we have an error, we want to quit the program. We don't want to keep running it because it can create a cascade effect and can create more errors, right? So we can say return 0 or just a value, right? So now let's compile the program and let's run it. And as you can see, we have error number 2 and error no such file or directory. Okay, so it is telling us that the error code is number 2 and the error description is no such file or directory. So it means the file doesn't exist. Okay, so that's how we handle errors. So we actually don't need this column right there. Okay, so we have learned how to open files, how to write files, how to read files, and how to handle errors when we read files. Okay, so something useful on C is also recursion. So what does recursion mean? Well, recursion enables us to call the current method from inside itself. Okay, so let's run first of all the program in its current state, and it still says error, so we will change my file 1 to my file. Okay, and as you can see, it says hello file, so which is correct. So now let's try to do something. We will include the following library we used in one of the previous tutorials, was the unistd.h that we used to sleep, and we will use it to sleep it again right here. So as I was telling you, recursion enables us to call the current method from inside itself, right? So here I will call the main method again. Okay, this means basically the same as we did previously with the goto method, right? So I will call the main method again, and it will be called again and again and again and so on. But to avoid very fast output, I will sleep 1 second before calling the method. Okay, so I'm calling main from inside the main method. That's what basically recursion is. Of course, you can have lots of more complex methods that have parameters and create new maybe values and maybe more recursion, but we will just learn it, right? So let's compile the program and let's run it. And as you can see, it keeps printing hello file, hello file, hello file. So this is recursion, right? So basically, that's how it works. We just call it from inside itself. So to avoid repetition, I will delete these two now that we have learned what recursion means. Recursion is really application specific, okay, or algorithm specific. So yeah. Now, what else that we have, something else that we haven't learned yet is how to pass arguments to our program. Let me explain. So when we start a program from the terminal, right now to start it, I just type /C1 and I press enter and the program starts, right? So let me recompile it. So, and the program starts, right? But now I want to pass an argument, for example, C1, and then I'm gonna say this is an argument, for example. And if I pass it, nothing happens, right? So how can I use that feature? How can I use it? Well, first, here on the main declaration, I will declare some parameters. The first one will be an integer, which will be named argc, which is kind of argument count. And the second parameter will be a car pointer to argv array. So the first parameter basically tells us how many parameters were passed to us, and the second parameter tells us which parameters were passed. Okay? So now let's try to check how this works. Okay? So just before these file definitions, I will check if argc, so arg count, is equal to 2. Okay? And now we will print f, and I will print argc is 2. Okay, new line. Okay, so now we will figure out when argc is 2. So let's compile the program and let's run it, and I will pass hello. And when we pass hello, then we have arg count is 2. So basically the first argument is the kind of the program itself, okay? And second is the actual argument we passed, okay? Okay, and in this case we want to just pass one argument, right? So I'll say else if argc is greater than 2, okay? If the user somehow passed more than 2 arguments, which is actually one argument, because the kind of program name doesn't count. So if argc is greater than 2, we will print, we'll say printf, and we'll print something like too many arguments. Okay? And after we do that, we will return 0, right? So let's compile it and run again. And if we pass just the hello argument, it works. But if I pass hello and then I will pass world, it says too many arguments. Okay? So because it has 3 arguments, it is 1, 2, and the program name is 3, right? So too many arguments. Now, else, if it's not 2 and it's not greater than 2, then it should be less than 2. And in this case, we will print f too few arguments. Okay? So now if we, okay, let's compile the program again, and if we run the program without any argument, it will say too few arguments. Okay, so this is how we handle the arguments that are passed to our program via the terminal, right? So that's how we kind of know how many arguments we have. In this case, we can also return 0 to avoid further execution. So, okay. And if we pass the right number of arguments, what we want to do is to know which was the actual argument we received. Okay? So to that we'll go ahead and print f, and we will print double quotes %s, new line, and here I will print argb at 1. Okay, that's the argument we receive. Okay, so if we go ahead and compile and then run the program with the hello argument, or just one whatever argument, and we pass, and it says arg is 2, it says hello, which is the argument, and hello file. So if I pass something different than hello, like fruit, okay, it says argc is 2, fruit, and hello file, right? So pretty easy to understand this concept. Okay, so that's it basically of how the C programming language works. And now we will check a bit on how the compiler works, right? So we will open the CC file we created previously, and as you can see here, we have a very simple compilation script which only says clang c1.c minus o c1, which means get this file and compile it and write the executable file with this c1 name, right? Which is okay. Now, if we have more programs or more complex programs, we want those programs to run faster. For that, we can enable the optimizing compiler with optimization flags, okay? To enable the optimization flags, we can do minus O, which is capital O. So if we, let me see, if I run this again, it takes a little bit more to compile, okay? And if I, so this is not noticeable, but if you have a lot of large algorithm, okay, it's just, and these optimization flags will optimize the code to run faster, right? So apart from that, there's also optimization levels like O2, for example. Press O2, it still will compile and have a different level of optimization. And we also have O3, which is an even kind of a more powerful level of optimization. So that's basically the flags we can learn about how to code in C. We can also add additional flags. For example, to add a new flag, we just type minus and the flag we want to add. For example, capital W A L L, which means enable all warnings. Okay, and capital W extra. Okay, which means enable extra warnings if needed. Okay, and we also have the option to treat warnings as errors. So I can say W error, I think. So let me check if that's correct. Yeah, hope that seems to be correct. And since we don't have any warnings, so the program doesn't do anything, which is cool, of course, to not have warnings. So this is how kind of warnings work. This is also how kind of the compiler works. How can we set this? And there's really lots of different flags we can use. For example, we want to print the square root of a number, but the C programming language doesn't include that built-in, so we have to include the math library. To include the math library, we just type minus LM, which is kind of means library of math, right? So if we go right here, we can now include the math library. So you can say include math.h actually, okay? So when we include math.h, so let me delete all of this because we don't need it anymore. Okay, so when we include math.h, now I can print the square root of a number. Okay, so to print the square root of a number, I just call sqrt, okay, and I will pass a number, for example, 16, right? And I will store this in a double, I think, so double square root, and I have the square root of 16. So if I want to print this, I would say printf a float or double in this case. I think f will be enough, so let's check. And of course a new line, and here we will press the square root. Okay, and now we're gonna compile it. Oh, oops, we have unused parameters. As you can see, this means treat warnings as errors. So the flag we just used is telling us that we are not using these two parameters. Okay, so when we forget to do something, these parameters will tell us. Okay, so basically, if we don't use it, then why you have it, right? So we delete this and we compile it again, and we run it again. As you can see, we have the square root of 16, which everyone knows, right? But what about the square root of 17? Kind of tricky one, right? So we compile it, and here we have the square root of 17. By the way, this is not possible. This won't be possible if we didn't include the math right here and also the LM flag right here. So with those two flags, we can include, we are able to get the math functions, which are many more. To open and know what these files contain in VS Code, it's very easy to do. We will just hold down the Control key, and then we will press on the file name. And as you can see, a file has opened right here, which has a license, the GNU license, and all of this. And it has, lots of code that enables us to know which features this library contains, right? So as you can see right here, we can also calculate the cosine, the sine, all of these mathematical functions inside this math library. Logarithms, logarithm 10, powers, a square root, which we just used, and lots of things I don't even understand what they are for. So we have lots of different exponents, everything math, okay? So that's how we can open this. And if you want to open stdio.h, we'll press Control and we'll click on the library name. And again, if we scroll down, we will find that it includes stdio. And if we click on that again, we will find that it also has these new parameters like here, and it includes CSTDO. And if you open this again, kind of a tree, being open and opening this kind of things, and here we have the functions that this library is able to use. We can keep opening and get the function that we are able to call, right? So this is basically how to program in C with Visual Studio Code and CLang, but you can also use GCC, which are pretty similar. So like, let's change CLang with GCC. Okay, I think I have installed it. So if we do that and I press CC, then it is basically the same. As you can see, both of these are the same, but I'm more used to CLang, but both are great. Okay, so that's it for this video, and that's it for this C tutorial. I hope you enjoyed it, and I see you in a future course. Thanks for watching. Bye.